like I mentioned, it's an honor to be here with you guys, working with you all, and also to be working on this project where I will be discussing the challenges of commercializing nanotechnology. Before we go into the challenges itself, something I want to discuss is what is happening around the globe with nanotechnology. When you look at a global aspect, there have been 3.7 million papers registered, just patents that have been registered just in 2024 alone. 1 million of patents which have been accepted belong to nanotechnology. We can understand that this technology is growing at a rapid pace in terms of research and in terms of what we can do with it. Similarly, in India, a recent boom has come up in the semiconductor industry with 76,000 crores being allocated towards the semiconductor mission. This is also not new to our country, considering the nano mission has existed in our country since 2007. Next, I'd like to talk about what these nanomaterials and you all are making can contribute towards and are already contributing towards today. Electronics and semiconductors, all of the silicon wafers that we're making and sending out. Energy storage and batteries. The battery efficiency increases greatly, almost by 40% just by using a nanomaterial as opposed to regular materials. Clean energy and environment, we know that using nanomaterials can reduce the carbon emissions of using in any kind of fuel use. Aerospace and defense, again, this is a protected industry. Healthcare and biomedicine, I believe a colleague of mine has presented yesterday itself the impact of nanotechnology in cancer research and industrial and advanced manufacturing. All of this is really important. Why? Because there's cost efficiency which benefits these companies that are using nanomaterials. However, most companies aren't using this yet. Now, what is stopping people from using this? One is the fact that there is a huge cost of switching from existing materials, existing suppliers to a new source and a new supplier with nanomaterials. We see that research and discovery is happening in the labs. IT and publications are happening. We've seen the numbers. Development and prototyping also happening. Commercialization at scale is where the biggest issue comes in. Why? Companies are afraid of using nanotechnology and nanomaterials considering this hasn't been done before. And of course, considering this hadn't been done at that scale before, and also because the price of nanomaterials at the first glance is almost 10 times the price of your regular materials. This is a concept that is called as the value of depth in business. The value of depth translates to something where there's a problem in going from research to commercialization because of a large investment that's required, a large amount of infrastructure that's required, a large amount of customer base that's required, which isn't readily available. A lot of companies that do try to commercialize start off really well with a solid idea, but they're not able to reach the final step where that idea turns into a valid business. So how do we at Ultrananotech have an opportunity to bridge this gap? While this is a gap we are facing ourselves, I think given the fact that Nano Mission has been in India for 2007, we know that yes, there are government grants, yes, there is support, but if we don't step up ourselves, there isn't much change that's going to come into the industry. All of these steps are steps that I have discussed already. The key steps here when we come in are as material suppliers and technology providers and commercialization partners and enablers. A keyword here is partners. We are not just suppliers. The reason we are partners is all of you here are extremely specialized in your fields. You know perhaps more than the person you're selling to most of the time. You can always guide them on how to use the materials, what material needs to be used where, and the correct specifications that is required for their work, which helps to prove to them as well that this is what is required. It is not the regular materials. Now, how do we fit in here? We've seen that Ultrananotech right now imports most of what we sell. A very large portion of what we're importing comes in from China, US, These two countries are the majority. When we look at procurement, a large part of what you all do every day is handling customs, couriers, people that are coming in. Now imagine each individual customer of yours having to deal with that individually. We bridge that gap so that they don't have to deal with that, and we are making the process much simpler for every single customer out there. Next is material discovery. The fact that there are so many options in our catalog and options that are being added every day through research, through our own development. Next is research partnerships. So you work with a lot of people outside who are coming to you as customers and working with you directly because they know the worth of what you're selling. Next is commercialization support. This is where I believe we need to bring a change, in the sense that what we do right now is sell. What we need to do ahead is consult. We need to talk to people and tell them that using nanomaterial at this level will give you a return on your investment of this amount. We need to be able to break down the business, break down the numbers, so that they understand how to implement it, when to implement it, how much it costs to make the shift. Next is technical expertise. Something I've been hearing since the very first day I've stepped in is that, again, all of you are really good at what you do, you know what you're doing, and perhaps some of the best people at it. So I hope all of you remember this. I don't think you were a part of it, I'm really sorry. So this is called an internal factor matrix that discusses about the strengths and weaknesses of the organizations. Now, when most of you filled in something you didn't see was the weight column. The weight column is something that identifies how much of an impact that particular factor has towards our business and what we're standing for. We see that within our strengths, our biggest strengths is again our technical consulting expertise. We have expertise, now we just decide how we put that out. Next is customer-centric approach. Each of you deal with customers on a one-to-one basis. It's always on calls, it's always taking multiple calls a day, reaching out to customers, be it regarding payments, specifications, data, shipping, reshipping. All of that is handled in a very human way without any interference of, say, chatbots or other available needs. Weaknesses. Now, one weakness that had a really high weightage given from the start and then was also scored low was that our customer base is largely researchers. Our customer base is not companies or commercial orders where you're supplying a large volume. It's always a small volume, 50 grams, 100 grams. It's not more, it's not, say, 30, 40 kgs at a time. It's not a recurring order where you're constantly supplying to one firm every few months or every few years. So this, I feel, is what tells us that, all right, this is what is wrong. This is what we have with us, and how are we going to use that to fix it? So a really good thing here is the IFE matrix actually scores each company out of 4. And we stand at a 2.65, which is above the average of 2.5. So technically we're safe. But 2.65 also leaves a whole lot of room for improvement. So this is another another model. It's called the value proposition model. Now what this does is it looks at customers, as in here I refer to industrial customers, not our regular research customers, their work, what they need to do, and what pains them in this work, what is making that work difficult for them, and what could, and what could be good for them, right? So that is what we have as pains and gains. On the other side, we have us, Ultrananotech, who can, with the products and services that we provide, be the gain creators, as in give them that benefit, and more importantly, be the pain relievers. Right? So we'll see that some of the pains that we have here is uncertainty in performance and material reliability. Right now, a lot of the material that comes in or that we produce, we test out of house. We do not have testing in house, which costs a lot of time and money also. Bringing this as a function in house makes it much easier for the companies we supply to trust what we're selling at a much shorter notice. Next, complex integration and compatibility.
Can you go in gains part? Gain part, can you elaborate a bit?
Yes. So, like I mentioned, nanomaterials have a much better usage compared to regular materials. Something I was told in the early days, if you're using titanium oxide in paint, the amount of nanomaterial you would have to use per liter of paint is much lesser compared to how much micron you would be using. So in that sense, it's increasing your performance, not just in terms of lesser amount in terms of efficiency, but also in terms of quality. Like I mentioned, using nanomaterials in batteries reduces carbon emissions by 40%. So things like that. Then trusted partner with deep technical knowledge, we have to become that. We are already that, but we are a trusted supplier at this point. We need to become the partners so that they're open with their business concerns and not just with their technical concerns. Next is reduce time to market. Like I said, if we start bringing our own in-house testing, if we bring our own in-house production for things like silicon wafers or sputtering nuggets that you are constantly importing, right? You're also importing it on an order-to-order basis where sometimes the customer is having to wait almost 20 to 25 days. If we could produce these in-house, it would be a huge benefit. Of course, on the other hand, there's the fact that machinery for these is extremely expensive. We know that the machine we have right now is about 40 lakhs, I believe, in cost. Even more. So imagine just to double your production, the amount of cost that would go into it. So that is
One accessory itself just we purchased. Just yesterday I came 30 plus. Only accessories.
exactly. So that is another part of the value of debt. That in industries like deep tech, the investment is huge. It is substantially huge to the point where there's no guarantee that you will be able to recover that in a set number of years. It's almost a sunken cost. You don't have an option of recovery. So that is where we need to step in and become.
Very frankly, due to this only, to minimize the risk, we are moving slow, at slow pace. Just I am giving an example. We purchased the machine in 2024. Okay, so 1 year we need just to understand whether we can produce really something good, whether we can design materials, production capability, and all those things. Lot of trial and error. And after 1.5 years, we came to know that okay, it will work. So then only we ordered that another accessories where 2 jars, zirconia jar. We could have ordered much earlier and we could have produced lot more nano, but we were not enough confident at that point of time. So yeah.
Exactly. So also the fact that a lot of these machines that we're using, they are not made in India. They are mostly imported. I believe our machinery is German. So you would require German personnel or German informatics to understand what to do with these machines. They have built it, they know the conditions to which it runs best, right? Like for your machine, I believe it needs a downtime every few cycles. That fact that no one except the person who made the machine will know it. No one will know what is the optimal condition that machine needs to be run at.
This is the bottleneck. This is the main reason it took so long time. What has happened? The engineer who came here to install the machine, he gave very little information or no information. Basically, how to run the machine or what is the standard optimized way to run the machine. We waited for 1.5 years, then we got a right engineer, one engineer from Hyderabad. He came and he explained, and after that only we were able to run the machine. Earlier we were not because of that. So, surrounding environment is also hugely responsible actually. For example, the guy who came, he was not having adequate knowledge on that machine. Yeah.
So that is what, again, I mean when I say we've understood that our surroundings aren't necessarily supportive towards the business that we have. We've seen announcements of so many government grants, so many funding ideas, but how many of them have we actually been able to avail ourselves?
Nothing yet.
Nothing.
Exactly. There is, I'm not saying there isn't, but the fact that it doesn't necessarily apply to the stage of business we are at or to the environment we are in. It just leaves us with one option, and that is stepping up ourselves to take over that role and to understand. So now that you've understood this machine, now you're getting access.
So I think this type of risk is more innovative business where risk is also very huge. That a lot of startup gets die also. Yeah.
In deep tech or in nanotech itself, 95% of the startups do not make it past the 5th year.
Right.
So again, congratulations, 10th year. So you've survived double what most organizations
Correct.
survive on their own.
That's okay.
How do we mitigate adoption barrier risks? A thing I mentioned earlier was there is a huge cost of switching. The machinery that the consumers, or I say consumers, I mean the industrialists, are using may not necessarily be suitable for the materials that we're providing. They may have to change their formulation, their machinery, their labor, who is working how. And that is a huge cost to a business to absorb at one go. It's not really possible to switch overnight. So there are some things that we need to do to help them in making this change. Because we know that if we don't, it will most likely not happen unless it becomes a regulatory requirement. Uncertainty in material qualification. This point is something that comes up again and again. If we had in-house testing, if we were able to guarantee the quality of our materials, things that we are producing much faster, it gives them a procurement route that is high speed and reliable. Next is integration and process complexity. The fact that nanomaterials require so little. You said with machinery, we didn't understand that this is how the machine has to be used. The same thing is going to happen to them. They are not going to understand how much of nanomaterial is required to be used to produce the same quantity that they were producing before, or how to change. That is something again we have to support with. Supply chain availability and risk. Now this is a huge thing because per my research in India, there's only 100 to 150 firms that are currently in nanomaterials. That is a very small number if you think about it. Switching to this, if there is a slight inconvenience, say the borders are closed, right? Considering most of us are currently importing, say the borders get shut down, their supply is cut off. They won't have an alternative source. Whereas for regular materials, it's very easy to source from anywhere or everywhere at a much cheaper rate. Next is uncertain ROI and business case. Again, the fact that nanomaterials cost 10 times what the regular material would cost is huge for them. That the idea of spending so much at one shot itself disturbs them. That is the first time where people see the price and then turn away.
Yeah.
They won't even consider the
we get call from India one, and they'll start with I need 1 kg this nano powder. So what is to be the price? So we initially hesitate to tell any number on phone because we know he gets shocked. So we tell during the 28 kg, then he will, yes, he will insist and he will press up and then we tell the number. The moment we tell the number, immediately either he will cut the call or I will say I will come back to you.
Exactly.
This is what India want.
The people of the industry aren't aware that
So what has happened because of this? So when Indian call comes, whether in my phone or Mosami's phone, we reluctant to pick the call because we get discouraged by this call actually. So because most of these negative things we get from India Mart, so sometimes we don't feel to pick the call.
Yes. So the same thing is happening to you because you experienced that high price.
Correct.
That impact of someone putting the call down so many times. You're disturbed by the idea of going back into it. The same is what they are facing. They don't know that by spending 10 times, I could also potentially make 10 times the output. Or in a much easier, cheaper, safer way for them. So how do we become the backbone, right? Like I mentioned, it is for us to step up, for us to make the market that we want to be in. Innovation pipeline accelerator. We are already doing this at a very high level. I've heard that Sir personally has guided multiple people in their research itself when providing materials, saying, oh, that is how you need to do it to get it through. We're already helping with that. Digital platform and knowledge engine. This is also something that honestly I really appreciate that you've done. The fact that you're putting blogs out, me, a business student, would never know what nanomaterials is. While I was doing this, I went through your blogs. I found a bunch of very different articles on various uses. Now, business people don't know it. Business people are usually the ones making decisions, and we are the ones that see the price and freak out. Right? So if you can change that mindset, if you can educate the people in front of you, they are much more likely to buy from you, which is a step you've already taken. Next is advanced capabilities and infra. Right now we have just one lab. Right? I've already heard that you are looking at expanding and potentially opening a second lab, getting more investment and starting production. So hopefully that also happens. That will benefit you in a huge way. Why? Because you will now be able to access commercial customers. It's not that commercial customers do not come to you at all. You had to refuse orders because of the quantity that they require, and it's just simply not possible for us to meet that requirement. Next, strategic accounts and solution partnerships. This is again something that all of you benefit from. I've realized you have relationships with your customers, even though you're the tech people. Usually people would put another relationship manager or someone who does customer support in front and leave them to just handle the person on the other end. Whereas in this case, we're providing much more personalized support in terms of, again, what they need to do as well. Global market expansion. Now, we currently import just from 3 countries. That means we ourselves are at a risk of concentration, right? For a lot of materials, butter targets are always imported, right? So things like this could also negatively impact our business. Finally is industry standards and thought leadership. The industry standards will change. I'm expecting in the next 5 years, especially given that 76,000 crore investment that the government has just made or has promised to make. Now, given that this sector is going to get a lot of media attention, a lot of mass market attention regardless. Now, it is up to us on whether we can cultivate that attention into a proper thought, into a proper process of making sure that nanomaterials is the way to go forward. So, ultimately, what happens when we bring all of these changes to our business, when we go on? The business impact. We will, of course, have higher sales, higher revenue, equals higher profit. Everyone happy with that. You'll have a more diversified customer portfolio. I wasn't able to do the exact research for this, but I noticed that a large amount of your sales is in your research people. It's almost 80 to 90% that's going to researchers, institutions, or the government. Next is stronger customer retention. When you become consultants as opposed to suppliers, the cost of switching away from you also becomes a thing. People want that support, people are happy with that support. People would pay a premium to keep that support in place than switch away to someone else who may be supplying at a cheaper rate. Next, industry impact. So, of course, with everything that we bring into the picture, hopefully nanomaterials will start to be accepted at a greater rate in the industry overall, reduce commercialization barriers once it has increased in India. So commercialization as an issue has been discussed since 2007-2008 in UK and China, in the other countries. Whereas this is really posing to be an issue for us. They're already ahead in that sense because they've developed that market. So once we can be the pioneers of changing that market, we are also opening that pathway for others to lead, which is competition. But it's still a benefit to the industry and to our customer base ultimately. Next is improved product innovation. With what we're doing, we can support research even further than we we are now. 3.7 million patents were applied in 2024. But that 1 million is not just from 2024. That 1 million is from all of the years before. While yes, 1 million is a big number, we still see that it's very concentrated and most of the research doesn't make it out of the labs. National impact. So India is looking towards a deep tech ecosystem. We're moving away from our startup culture. It's more about technology. It's a semiconductor race. It is how far ahead we can get. Then it's supposed Make in India, considering we would be producing in-house as opposed to importing. And it of course increases global competitiveness because we could also start supplying to those we are buying from. Right? Instead of buying from China, instead of buying from USA, we could increase our exports. Now also our exports are what? Maybe 2 orders every quarter at best. So we could hugely improve that if our category of in-house products, if we made sure that we are the source instead of we are the middleman. So I think that is all I had to say.
So industry, other than industry, in fact another thing you just mentioned, no? That export.
Yes.
Even we are lucky to take the export. You don't believe. Whenever any export comes, whenever anybody asks us to give the price in dollar, we hesitate. Let me explain why.